Hello everyone. In this video, I will discuss law of radicals. To start off, let's review first basic fundamentals of radicals. So if we have an expression nth root of A, so your A here in the square root is the radicand, while the quantity here, which is n, is your index. So of course, the symbol of this symbol, this one, is your radical sign. So for example, we have cube root of 6. So your index would be this one, 3. While your radicand is the quantity here inside, which is, in this case, 6. So whatever be the value inside the square root is your radicand. So in this example, so the radicand is 6. So how to transform exponential to radical? So this is not radical from, but instead that is radical form. So if you have x raised to the power of m over n, that is exponential form. So your exponential form into radical will be this one, nth root of x raised to m. So this, whatever be the value or the quantity in the denominator of the exponent would be the basis of the root, which is this one. So for example, you have 3 here, and that is cube root. So if you have 2 here value, that is square root. So the exponent of the base, which is m, would be this one. So again, this is the exponent, and your n is the basis of the root. So that's why we have the nth root of x raised to m. So for example, x raised to 1/3. So 1 is your exponent of the base x, while 3 is the root of x. So therefore, cube root of x raised to 1. So you can simplify x raised to 1, or simply it is equal to cube root of x. That is how to transform the exponential into radical form. So in short, you simply look into the value or in the denominator of the base x, and that will be the basis for the root, while whatever be the value in the numerator of the fraction of the x will be the basis of the exponent of base x. So that is how to transform exponential to radical form. So let's take review about the rules. So for the first one, so the nth root of x raised to 0. So again, any quantity inside the parentheses or any variable raised to 0, it is always equal to 1. Regardless how complicated the expression here. If it is raised to 0, the answer always be equal to 1. So for example, problem number 1 or sample problem number 1, the fourth root of y. So since this is enclosed by 0, the answer is 1. So another example, problem number 2. So it involves two terms, binomial, 5 minus square root of y, but the whole quantity here inside the parenthesis is raised to 0. So with that, the answer is also equal to 1. As I mentioned earlier, whatever with the quantity, whatever, or even though how complicated the expression inside the parenthesis, if it is raised to 0, it is always equal to 1. Now for the rule number 2, or law number 2, so as you have noticed in this case, you have x raised to n and n here as the root. So it is the same. The exponent of base x is equal to the root. So therefore, it will cancel out the exponent and the root. So therefore, the answer would be x only. Okay? So that is how to simplify if the base and if the exponent and the root of the base is equal, then it will cancel out the base, exponent, and the root. So it will remain its base x. So for example, the fifth root of y5. So you have noticed that the base and the exponent, or I mean the exponent of the base, which is here 5, is 1, and the root is the same, so it will cancel out, so it will remain the base y. So therefore the answer is y. So another example here, cube root of 125. So if you try to simplify 125, 125 can be written into 5 cubed. So in case of the problems on the board exam, so all you have to do is to verify first if it involves numbers. If this can be written into exponential. So like for this case, 125. And if you're just looking 125 and then there is no exponent here. But as you have noticed, if you already observe that it can be written into 5 cube, then you do the simplification. So cube root of 125 is equal to cube root of 5 cube. Because 5 times 5, that is 25, times 5 is equal to 125. Now, as you have observed here, so you have noticed that their bases are, their exponent and the root are the same, so it will cancel out. So the remaining here is 5, which is your final answer. So for rule number 3, this is product of radicals. So if you have nth root of x, y, it involves product here, x and y. So it can be separated each individually. So nth root of x, and the dot here is times the nth root of y. For example, the cube root of 8z cube. So if it involves number, So check first if what is the cube root of x. So this is based upon the rule, it can be separated mathematically. So that is cube root of 8 times the cube root of z. Now simplifying further, your 8 can be written as 2 raised to 3 because 2 times 2 is 4 times 2 is 8. So if it involves numbers, so check if this is the correct. So like for this example, k is 8. So you try to evaluate what is the cube root of 8. So if you say 2, 2 times 2, 4 times 2, 8. So that is correct. 8 is equal to 2 cube. So if you do not know how to solve for the cube root, just simply pick choices in the board exam. Pick choices. So if you see the number in the choices 2, so you try to solve what is 2 cube if it is equal to 8. Now, simplifying further, so therefore, the exponent of base 2 and the root is the same, so it will cancel out. So it will remain 2 cube. 2 only. I mean 2 only. Same with z, the exponent and the root is cancelled. So the remaining here is only z, it will cancel out. And then the answer is, the result of this is 2, and the result of this one is z. So you multiply 2 times z, that is 2z. You cannot combine variable with the constant. So therefore, this is the final answer. Now, if it involves quotient of radicals, so you can separate just like product. So nth root of x and then the nth root of y. You can do separate each quantity. Provided that if whatever be the root, so you copy the root here. So let's have an example for that rule. For problem number 1. So this is my problem number 1. So the square root of 20a7 and the square root of 5a cubed. So as you have observed that square root of 20 cannot be cube root, but instead it can be simplified. It can be combined into, in this case. So if you do like this, you enclose as 1, 20a7 and 5a cubed. So this is quotient rule under the law of radicals. Now, by law of exponent, 20 divided by 5, that is 4. And then a7 and a, that is quotient of exponent. So if the same base, subtract the exponent of the numerator by its denominator. So 7 minus 3. So simplifying further, that is 4a4. Now, what is the square root of 4a4? So for 4, or by quotient rule, it can be separated, the square root of 4 and a4, square root of a4. Now, for square root of 4, that is, a4 is equal to the square root of a squared times a squared, or square root of a squared times a squared. And that is 2a squared. Because the square root of a4 is a squared, and the square root of 4 is 2. So it's easy to solve for the square root because this is the way. So I'll give you another example, and I will write this one in the paint. So for example, you have the square root of a 6. So instead of writing this one like this one, a squared times a squared times a squared, that's a6. Then the result of a squared here is a And the result of this one is a also. And the result of a squared here is a. So therefore, the answer is a cube. So instead of doing that, or in that process, all you have to do is to divide the exponent by its root, since 6 is the exponent and the root is 2 because square root. So 6 divided by 2, that is 3. So a sub 3. So another example, if you have the fourth root of a 20, okay, so a 20. So you simply divide the exponent by the root, which is 4. So 20 divided by 4, that is a sub 5. Okay? That is how to solve or how to evaluate radicals simply under this law or rule. If it involves number, like for example 16, A8, so what is square root of 16? That is 4. What is square root of A4? So instead of breaking down into exponent, so all you have to do, if it involves exponent, you divide exponent of the base 8 by the 2 or the root. 8 divided by 2 here, 2 is the root. So 8 divided by 2, that is 4. So therefore, the answer is 4A4. So that is the answer for this example. So let's go back with the slides, or the slide. So another law here is the nth root of the nth root of x. So as you have noticed that this is another index m, another index n, and the base is raised to these two index. So all you have to do is to multiply their index or indexes. So m multiplied by n. So of x. So that. What is the mn root of x? So the operation here is multiplication. So for example, problem number 1. What is the cube root of the square root of 2? So this is square root of 2, but this square root of 2 is being cube root of this expression, square root of 2. What is the cube root of square root of 2? So therefore, you simply multiply its index. So understand, and it is understandable that you have here square root, so you have the index 2. So 2, then the index here is 3. So 3. So you multiply operationally, that is the 6th root of 2. That is how to evaluate if it involves 2 or more index or indexes. So another example here, the square root of the square root of the cube root of x6. So you have here the index 2, you have also the index here 2, and you have index 3. So the whole thing, it would be multiplied 2 times 2 times 3. Then copy the radicand x6. So therefore, 12 root of x raised to 6. Or if you do it exponentially, from radical to exponential, this is your exponent and this is your root. Again, the base, the exponent would be put in the numerator, and the root will be put in the, or it will be written on the denominator of the fraction of the base x. So that is 6 over 12. And 6 over 12, by fraction simplification, this can be simplified into 1/2. So therefore, x raised to 1/2, because 6 divided by 6 is 1 and 12 divided by 6 is 2. So x 1/2. So transforming this again to radical, so that is square root of x. So because the root here is 2, so you have 2 here. And then the exponent of base x is 1. So therefore, the square root of x is the answer. Now, this is another rule. You can write the x root, or I mean the nth root of xm into nth root of x raised to n. So the m would be outside the parentheses as your exponent. Okay, or the nth root of x is raised to exponent m. You can write in this way. Sample problem 1. So what is n, or I mean what is the 8th root of a7? So this is your exponent 7 and this is your root. So you can write in this way, the 8th root of 2 raised to 7. So I'm just showing you an example here. So if square root of 2 can be simplified, then you do it simplification. You do the simplification. So since square root of, or the nth root of 8 is cannot be simplified, cannot be factor, so that is the answer, nth root of square root of 2. Or the nth root of 2 raised to 7. So that is how to apply the law, or the rule number is 6, which is nth root of xm is equal to nth root of x raised to m. So problem number 2. So if you have, in this example, so this is the exponent, this is the root, and this is the radical. So you can write in this way. So as you have noticed, the cube root of 8x cubed can be simplified. The cube root of 8 is 2, and the cube root of x cubed is x. So this is raised to 4. Simplifying further by law of exponent, if you have 2x raised to 4, it can be written as 2, 4. So correction, this is 2, 4. So 2 raised to 4 times x raised to 4. So therefore the answer is, that is not 8, that is 16. 16, I mean 16 x raised to the, okay, so this one. So 2, 4, that is 16. And x4, you copy here, 16 x raised to 4. So what if you have an example here that it cannot be square root? Like for example, you have the square root of a raised to 7. So this cannot be factors of 7 is not divisible by 2. So all you have to do is to write up to what limit or what even the 2 can be divisible by this 7. So in this case, up to 6 only, a6. So that one. So with this, you can divide directly. 6 divided by 2, that is a cube. So since a here cannot be square root, so it will stay in the, or inside the radical. So again, for square root of a6, that is a cube. But your square root of a cannot be square root, so it will stay in the radical, or inside the radical symbol. So that is square root of a. So another example, you have the cube root of 48. A sub 9. I mean, a sub 10. So in this case, you can write cube root of 48 times the cube root of a sub 10. So the cube root of 48 can be written into 6, cube root of 8 times 6. While cube root of A10 can be written into cube root of up to 9 only. So since A10 cannot be divisible by 3. So up to 9 only. So A9 times A. So in this case, what is cube root of 8? That is 2. So since 6 cannot be cube root, it will stay inside the radical. So cube root of 6. How about this one? Up to 3 only. 9 divided by 3, that is A sub 3. Since A here, the remaining A cannot be cube root, so it will stay inside the parenthesis or inside the radical symbol. That is cube root of A. So this is the final answer. Okay? That is how to simplify if the radical cannot be square root, cannot be cube root, and so on and so forth. Now, how about if it involves a conjugate? When we say conjugate, we have the same here, radical, but it matters only on the sign, plus and the minus. So let's review on the sum and difference of two squares. The rule of that is square root of this term minus the square of this term. So I'll show again in the paint. So review in the sum of difference of two squares. So if you have x squared minus y squared, so it is equal to this the square root of this one, x, minus or plus first the square root of y, which is y, the square root of y squared is y, and then plus minus. This is conjugate. So this is law of exponents, sum and difference of two squares, but if it involves radical, like for example, square root of x plus square root of y, and then square root of x minus square root of y. So sum and difference of two squares. So applying this one. So first is square the first term, or you squared x squared. Okay. Then minus, you square the second term. Okay. So as you have noticed that your square root of x raised to square can be written as square root of x squared. Likewise, square root of y squared. So since the root and the exponent are the same, so again, since the root are the same and the exponent are the same, so it will cancel out. Same here with y squared. So square root of x squared is x. Square root of y squared is y. That is why we have here x minus y. This is conjugate of radical. So for example here, the square root of x plus 2, the square root of x minus 2. So they have the same here, the first term and the second term, but it matters only in the plus and minus. So all you have to do is square root of x minus square root of 2 squared. Since it will cancel the exponent and the base, the root. So what remains here is inside the parentheses or inside the radical. So there is x, the square root of 2, that is 2. That is how to simplify problem number 2. 1. So another example here, the square root of a5, a plus 5 plus 3 plus a, the square root of a plus 5 minus square root of 3a. So it will cancel everything here, the radical, then minus, cancel, Then the remaining here is a plus 5 minus 3 plus a. So this is the solution. This one. So squared the first term minus squared the last term or the second term. To simplify further, it will cancel the radical. So the remaining here is the inside the radical symbol. So this is a plus 5. Same here with 3 plus a. So 3 plus a. But take note on the operation na minus, it is minus. So you copy minus here. Then you do the simplification of an expression or variable. So a plus 5 minus. So you apply distribution or distributive property. The negative 1 here will be distributed inside the parentheses. So this is a plus 5 minus 3 minus a by distributive property. Then, as you have noticed, the a will be cancelled because a minus a is 0. So 5 minus 3 is equal to 2. So what if it involves adding of radicals or subtraction of radicals? So a plus square root of x plus minus b square root of x. So you do addition and subtraction. So this is how to simplify if it involves addition or subtraction. So you just copy the radicand and then you subtract or you add their a and b. So whatever be the expression here, a and b, you add or subtract. Make it sure that once you add, the radicand must be the same. So in this case, since square root of x and square root of x, so you can add. So let's have an example to make it clear. So this is problem number 1. So for example, problem number 1, the cube root of 8 minus the 6 square root of 2 minus square root of 50. So they have different radical, 8, our radicand, I mean, 8, 2, and 50. But if you try to simplify cube root of 8, this can be written into 2. Or the answer is 2. Because 2 times 2 is 4 times 2, 8 times 2 is 8. Then this is 6 square root of 2. This is not square root of 5, but since this is 6 square root of 2, so therefore, minus your square root of 50 can be written into square root of 25 times 2. And what is square root of 25? That is 5. So your 5 will be outside the radical. So square root of 2 is square root of 2. So 5 square root of 2. As you have noticed that you have here a radicand which is square root of 2 and then square root of 2. So in that case, you can combine this 6 and 5. You subtract it operationally. So what is negative 6 minus 5? That is negative 11. Because that is the rule of subtraction of real numbers. So negative 6 minus 5, so it will change to plus. Then you do addition. So what is negative 6 plus negative 5? That is negative 11. So therefore, the final answer is 2 minus 11 square root of 2. So in short, if you have this example, square root of 3 plus 2 square root of 3 minus square root of 2 plus 5 square root of 2. So you cannot combine, if this is cube root lang. So cube root. So you cannot combine, so it is okay. So this is square root of 3 and this is 2 square root of 3. This one is square root of 2 and this is 5 square root of 2. So you cannot combine square root of 3 by square root of 2. So all you have to do is to combine this one and then this one. So what is square root of 3 plus square root of 2? So you add on their numerical coefficient. of the square root of 3. So understand here that this is 1. You have 1 here outside. So 1 plus 2, that is 3 square root of 3. So with this, so understand here that you have 1 here. So negative 1 plus 5. So the rule here is subtract the higher number with the lower number. So 5 minus 1, that is 4. And then since 5 has a positive sign and it is greater value, so you carry the sign. So plus 4 square root of 2. So again, you cannot combine radicand if they have different radicand. You cannot combine it different radicand. So in this case, this is the example. So again, you cannot combine square root of 2 by square root of 3. So you cannot combine, so the answer is this one. Okay? Likewise, if you have cube root of 5 and then the fourth root of x, so again, you cannot combine. So this is the answer. So go back to the slide. So we're done with that. So the answer is 2 minus 11 square root of 2. So another example here. This is second problem, number 2. 2 square root of 2x plus 4 square root of 2x. So they have the same radicand. So you have to do add their constant, 2 plus 4. Then you copy the radicand. So 2 plus 4 is not 4, but instead that is 6. 2 plus 4 is 6. So another example. 4y squared minus 4th root of y8. So observe first the given. If you solve radical, you observe first before you apply the law. If this can be simplified directly, then go for it. Like for this example, 4th root of y8. So this can be divided. This is divisible by 4. So 8 divided by 4, that is y squared. So in this case, 4y squared minus 2y squared. Then there is no radical here. So all you have to do is to simplify mathematically. 4y squared. So the same with low exponent, you cannot combine different exponent, or I mean different, that's correct, different variable. So you can only add it the same variable. So for example, y squared, so you can combine y squared. All you have to do is to copy the y squared and then you subtract their constant, 4 minus 2. And that is 2y squared. So rule number 8. So we're done for that. We're already done with this. So how to evaluate radical expression. So this time, I will share to you the easy way. So we will do pick choices. We will not do engineering solution or we will not show the solution, but all we have to do is to pick choices. So for example, you have, or you evaluate 2x, square root of 2x plus 3 minus 3 is equal to 0. So all you have to do is to assume or pick choices. So if we say that this is the shortcut, so if we say that the answer for this question is letter A, so we will verify these 3 in the given. Or we will substitute this value to the x here. So we will evaluate if this is equal to 0. So with that, so use the choices as your x value, which is equal to 3. And we will put that the value of that choices or choice to the expression. So square root of 2x plus 3 minus 3 would be at x is 3, therefore this is 2 times 3 plus 3 minus 3. Simplifying further, So I'm substituting here the value of x as the number that I am picking on the choices, assuming that 3 is the answer. Now, simplifying further, 2 times 3 is 6, plus 3 is 9. So what is square root of 9? That is 3. What is 3 minus 3? That is 0. So if it will equate or it satisfies left to right, so 0 is equal to 0, therefore that choice is correct. So 3 is the correct answer. So that is how, or the shortest way to simplify this expression. So you will not apply the engineering solution. All you have to do, if you do not know how to solve this, is to evaluate, or you pick choices, and if satisfies left to right, that is the answer. So another example here, and I will still apply the shortcut way by simply picking choices. So with this, shortcut again, assume that my answer is letter C, or the correct answer, assume only that the answer is C. The problem here is the number of attempts you choose or you verify is 4 times. At least you do 4 times, but you will have a greater chances that you pick or you will arrive correct answer. So it's okay for as long as you do only picking choices, and it saves also time rather than you do simplification of this one, and this involves too radical, so it takes time. But it is more easy that you use the shortcut. So this value would be substituted to the x here, or to the given. So the square root of 4x plus 5 minus x plus 4. So at x equals to 5, so this will become 4 times 5 plus 5. Likewise, square root of 5 plus 4, which is equal to 2. So we will verify that if this, upon substituting x to the expression, if this is equal to 2, then that is the answer. So we will check. So when we substitute 5 here, likewise with this one, so this will become square root of 20 plus 5, and you can combine 20 plus 5 and 5 plus 4. This is square root of 25 and square root of 9. Then square root of 5 is 5, then square root of 9 is 3. So what is 5 minus 3? That is 2. So as you have observed, that it satisfies, so it equates, it is equal. So 2 is equal to 2. So in that case, you have the correct choice. And that is the final answer. So 5 is the value of x that will satisfy the equation. So I hope that you do like this, and it will help you in simplifying or in evaluating the algebraic expression. So it's easy to use, or just simply picking choices. So again, thank you for listening. This is Engineer Larry Angelo Arcagnetti, Mathematics and Statistics Reviewer of Santo Niño Review Center. Keep on solving, practice, practice, practice. So that's the only way to master math. And you start love math so that it's easy to understand the topic. So that would be the end of my discussion. Thank you, and God bless everyone.